Welcome back to the next video in this series of cybersecurity. So we are looking at scanning the networks. Uh, so we were looking at different. Um, we are going to start with scanning the networks, but before we scan the networks, we want like to capture the packets of from the Ethernets from the interface cards. So we use Wireshark. So we use Wireshark uh, in almost all the missions. So we have Wireshark in SDC, we have Wireshark in London network, and we have Wireshark in Kali as well. So we can monitor the packets and see what is happening between the packets, between the interfaces when we are issuing certain commands as well. So we can just go start the packet captures. Possibly we are now going to capture the packets. Oops, sorry. Okay, no packet captured. So I'm going to capture it in um, ETH. Okay, hold on a second. Let's see where we are going to capture the packets here. IP address. So this is going to be 192.168.1.2, which is ETH1. So I'm just checking which Ethernet port I wanted to start with. So ETH1 is where, oops, right, okay, I stop it. I start it again. ETH1 is where I wanted to start the packet capture here. I will go back to my Windows server. I will stop this guy here. I will continue. All right, okay, we'll stop it here and let's capture internal Swansea because that's where this is going to work. Right. So we can capture the packet so we know what exactly is happening. And then let's move on here. Okay. So let's do a basic scan here. So I'm going to use Nmap. Uh, all right, let's do it. Nmap, and I'm going to scan 192.168.1.1, which is my server here. And it says that these are some of the ports uh, which it can see, and it says what are the status of it. So it says 977 closed TCP ports are there, uh, and then what are the port numbers, what protocols they use. Pretty much what we are finding out here is whether the host is up and running, and we can see that the host is running up and running. So if we can go into the Wireshark and stop the capture, you could see that from 192.168.1.2, it is sending to 192.168.1.2. Sorry, from 1.1, it gets, all right, okay. So we have to go to the top to see what is happening here. So you could see that from 1.2 it goes to 1.1 and it is using TCP protocol. So you go on here and you could see the Ethernet, the destinations where Ethernet to where you have IP MAC addresses. Here ICMP, you have uh, the IP addresses, and the time to live here is 43, the source and the destination, and the key point here is the TCP. So it is using a source port of 42,684 and the destination is 5510. And you could see the header length is 24 bits. It is sending a sync flag, right? So in the lectures we were talking about what sync flags are. So totally we have uh, uh, to be very short, to summarize you, we have like six TCP flags which we can start with. However, we have more than that. Okay, like around 8 TCP flags which we can talk about. But in general, in common, it is 6 flags which we'll be discussing about. And one of the flag is sync flag, which is a synchronized flag. This sync flag is used to initialize a connection between the host. So you could see the window size is 1024. The checksums are here, and what are the options we have? It says it's a TCP option, and you could also see that the sync flag does not contain a SACPERM option here. Severity level and the group protocol is here. Furthermore information, so here the point which we want to understand is it is going to send a sync flag. So actually what we are doing is there is a three-way handshake which we are working on in a TCP, right? So here it sends a sync flag. Let's go back to our server here. All right, the server is looking for 2.1. I am ready. So here you could see from 1.2 it gets all a TCP. 1.2 it gets let's close this once. I don't want to look at the Ethernet. So it sends a sync flag here, and then the conversation completeness is incomplete. It is a sync flag from 1.2 to 1.1, and from 1.1 to 1.2 it is a TCP. And here you could see that there is a reset and acknowledgement, RST and ACK. These are the two flags. So whenever what happens here is, so these are the different flags you have: a fin, a sync, a reset, a push, an acknowledgement written. So here it is sending a reset and an acknowledgement fan. So this is the difference. This is what you have to understand when you're running an nmap command. So it is sending a flag, okay, and then it is sending a sync flag to check what is the reply it is going to get, and based on that it comes to a conclusion, or it comes to a assumption of what is happening there. And then it says that the host is up, and these are the ports which are open or which are not responding. So it is about the three-way handshake you have. uh, so you send a sync flag first, and the sync flag is received here at this point. So literally what happens is, I'm trying to give you some information about it. So let's say literally what has happened here is, uh, from this mission we are sending an nmap command, so nmap 192.168.1.1. So what happens here is, from here it sends a sync flag here, a sync flag here, and then so there are two things: it sends the flag, the flag is received, and now it is going to send an acknowledgement flag. Okay, so this guy, what it will do is it will send back an acknowledgement to it. Oh, I have received um, your sync flag, your TCP communication. I have received it. So when it does that, and then the third way is it will say that, oh, okay, I have got it. And so this will not only just send an acknowledgement, it will send a sync acknowledgement. So this will say that, oh, okay, we have a successful connection established. So this is what the connection will happen. This is what will happen in a three-way handshake. And here you could see that, oops, sorry. So here you could see that uh, so you are getting communications with a sync flag and the acknowledgement flag. However, here it is not sending a sync and an acknowledgement. It is sending a reset and an acknowledgement. All right. So I will post a question here to you for a while to think about it. So what is going to happen when it sends a reset and an acknowledgement? Is that a three-way handshake is successful, or what is happening here? So I would say that when you have an acknowledgement and reset flag, and not a sync and a acknowledgement, which means that the connection is not established. It could be for any reason which we could further dive and to find out. It could be a half scan which is sent uh, by the nmap here when we issue it, so we can further do send some information and then find out. So here you could see that there is a sync flag which is coming in. So this is from 192.168.2.1 to 1.1, and from 2.1 to 1.1 you could see that there is a sync flag is set from 2.1 to 1.1, and f- then from 1.1 to 2.1 it is it is a reset and an acknowledgement. So it is not sending a sync and an acknowledgement, it is sending a reset and an acknowledgement, which means that the three-way handshake is not successful. So this is what a three-way handshake is all about. Right, so this is what I would like to show you. So when a three-way handshake in a TCP is a sync is sent, it has a sequential, uh, and the sync is received, the sync and an acknowledgement with a sequential and an acknowledgement for it. Here the acknowledgement is 101, it goes here, and then you could see that the sequential, only when the sync and acknowledgement is received you get an connection established, which is not happening here at this point with the command which has been issued here. So likewise we can issue a different uh, kind of commands to check what it happens. So my recommendation would be to go to nmap documentation and check what kind of commands you can use. You can further use different commands as well. So this is what I would refer you to, nmap.org, and then you could see there are different commands which you can use it and work around to find out. So end of the day, what we are going to look at here is scan the networks, find out, try to add furthermore information on what we have been doing, started to work on. Passively, we started footprinting, gather some information, note down the information, highlight those information, and then move on. Now, try to add more value to it, try to add more evidence to it, try to confirm it by using the scan, so that you know exactly what the issues are, what the vulnerabilities are, what are the ports which are open, what are the services which are available, kind of things. And from there we can move on to assessing the vulnerabilities, and then we can exploit it.